The determinant of a matrix is the sum of all signed elementary products. In this example, I'll use a 3 by 3 matrix. Here's the formula for the determinant. It's the sum of all signed elementary products. Since this is a 3 by 3, there will be 6, 3 positive and 3 negative. If I had numerical values for these, I could just put these into this formula and it will give me the determinant. To use cofactor expansion, I pick either a row or a column. I go along the row or column, take the determinant of that, multiply it by the entry. This will be positive, this will be negative, positive, negative, positive. If I decide to go along column, I always go along the top row. So going along top row, after I did that one, take this determinant, multiply it by this entry. Take this determinant, multiply it by this entry. So to see how this works, I look at the formula, this one. The cofactor expansion goes along either a row or a column. To see how this works, however you decide to do it, by either going along a row or a column, we're going to factor out that row or column. I go along the top row always. So what I'm going to do is I'm going to factor out this, this, and this. And that's what I've done. Go A11, here's A11, here's an A11. I factor out A11. And I'm left with A22, A33 minus A23, A32. Focusing on A11 and going along the top row, using the cofactor expansion, I take this determinant and then I multiply it by this. If I look at what I've done by factoring this out, A22, A33 minus A23, A32. A22, A33, A23, A32. And if I look at this, this is the formula for a 2 by 2 matrix. And more specifically, this 2 by 2 matrix. And it's being multiplied by A11. So that's where this idea comes from. And if you can imagine what's going to happen next, you'll probably come to the conclusion that it's going to be the same thing we've been doing for cofactor expansion. So going on to the next term, A12. Since this is a negative term, I'm going to factor out minus A12. A12, A12. So factoring this out, these signs will reverse. This will be negative, and this will be positive. So A21, A33 minus A23, A31. A21, A33. So let's change the color. A21, A33, and A23, A31. Again, this is the formula for a 2 by 2 matrix determinant, and more specifically this one. And it goes along like that. If you were to do the last one, I may as well do the last one, why the hell not? This, factor out A13, so here's 1, here's 1, factor this out, A21, A32, A22, A31, A21, A32, A22, A31. Another 2 by 2 matrix. It's being multiplied by A13. So this is where this comes from. And if you go along a different row, say this one, then you would factor these ones out. If you go along a column, then you factor these ones out. And you're going to get the same thing every single time. You're going to get the appropriate 2 by 2 determinant multiplied by this entry. And that's where this cofactor